Okay, as we said yesterday, everything we learn for the next 2.5 weeks should be review. This should be a review, nothing more. The first thing we're going to talk about is an algebraic expression. On the board, I have an algebraic expression. We read this as 3x squared. Now, the 3, this is called the numerical coefficient. The numerical coefficient. The x. This is referred to as your base, your variable. And this little 2 hanging above the x. What's that called? Help. Power or exponent. We'll call it the exponent. And these are the parts that make up an algebraic term. But what is a term? A term is separated by either a positive or negative sign. Example. So let's suppose we have 3a minus 4b plus 5. Algebraic expression. This is often referred to as a polynomial, meaning more than one term. How many terms are in this particular polynomial? How many? 3 terms. 3 terms. 1, 2, 3. What would be the coefficient of the second term? The coefficient of the second term. Help.
4.
Nope. He said 4. Negative 4. The sign goes with the number. The numerical coefficient is a negative 4. This is an algebraic expression, a polynomial with 3 terms. So now that we can identify an algebraic expression, how many terms are in this expression, we're going to go into the operations of algebraic expressions. And today we're going to discuss addition and subtraction of algebraic expressions, polynomial expressions. Now, example. Let's suppose we have the algebraic expression that I have on the board. My first question is, how many terms are involved with this expression? How many terms make up this polynomial? Help. Help. 6 terms. 6 terms. Now, what we're going to discuss now is addition of algebraic expressions. The thing you must remember, the only thing you can add are those terms that have exactly the same label. Exactly the same label. Now, if we read our first term in this expression, it says 5x squared. The 5 is the numerical coefficient. Everything else is the label. So x squared represents the label. How many terms in this polynomial have x squared as a label? 2. Those are the only 2 terms we can add. These 2. Now when we add algebraic expressions, we make sure they have the same label. Then all we do is add their coefficients. And we carry the label right along. So if we take a look at this, they have the same label. We're going to add their coefficients. Coefficients are 5 and negative 2. If we add these 2, we come out with 3. But what are we talking about? We're talking about x squares. So we have 3x squared. Now I put a light line through these so I know I used them. Our next label is x. There are two terms that have x for label. We're going to add their coefficients. A negative 7 and negative 3 is a negative 10. And this time we're talking about x's. Lastly, our numbers. We have a positive 4, negative 1, that's a positive 3. Therefore, the sum of those terms is equal to 3x squared minus 10x plus 3. That's simple. Okay? Let's try some. Here we go. Help. What do we have for an answer for this particular problem? 7a to the third, 7a cubed, either way. Let's see how we get it. They all have the same label. So all we have to do is add their coefficients. We have positive 5, negative 4, positive 6. So all you see, this is just an operation with adding sign numbers, no more. We have a positive 5 and a positive 6 is a positive 11, and a negative 4, well, that gives us a positive 7. You don't have to write the 7. You could if you want to. There's no harm done. Either way is correct. Positive 7, 7. And what are we talking about? We're talking about 7a to the third. Nice, easy. Okay, let's try another one. Let's suppose we have 2y squared minus 7y minus 3y minus 4y squared plus 14y. We have 2y squared minus 7y minus 3y minus 4y squared plus 14y. Okay, help. What do we get for yes?
Negative 2y squared plus 4y.
Negative 2y squared plus 4y. Does everybody agree with that? I agree with that. Could I write that as 4y minus 2y squared? Can I write it that way? Either way is okay. Usually when you'll find the answers in the back of the book, they'll lead off with the positive. But either way is correct. What they're showing you there is the order of the terms is not important, just as long as you have the same terms. Now, how does she get her answer? Our first label is y squared. There are two terms that have y squared for a label. So we're going to add their coefficients. We have a positive 2 and a negative 4. Well, that gives us a negative 2. We don't do anything with the labels, just drag it along. This is the same as saying 7 apples plus 5 apples. It's the same game. What do you get? You get 12 apples. What did you do? You added your coefficients, 7 and 5. And you dragged the apples right along. 7 plus 5 is 12, and you're talking about apples. Here we're talking about y squares. Our next label is y. There are three terms that contain y as a label. So we add their coefficients, negative 7, negative 3, and a positive 14. Addition of sign numbers. We have a negative 10 and a positive 14 gives us a positive 4y. And there's our answer. Again, I like to emphasize, you can write this as 4y minus 2y squared. They are exactly the same answer. Any questions on this? Well, let's give you another problem to see if you really understand what's happening. Let's suppose we have this. 2a to the third plus 4a to the second b minus 7ab to the second. And then we have 3ab to the second minus a squared minus 4a. Now let's change it. 3a squared b. See if you can find an answer, hopefully the correct one, in adding those two expressions. Negative 7ab squared. This is 3ab squared minus a to the second minus 3a to the second b minus 3a to the second b. Okay, everyone finished? My first question, Kathleen. How many terms did you get in your final answer? 4 terms. Okay, if you have 4 terms in your final answer, you have a good chance of having it right. There should be 4 terms. What you get for the answer, Kathleen?
2a to the third plus a to the second b minus 4ab to the second minus a to the second.
Very good. Very good. We want to combine like terms, add those terms that have the same label. Our first label is a to the third. How many terms do we have that have a to the third as a label? 1. So all we do is just bring it right down. Our next label is a squared b. How many terms have a squared b for a label? 2. Notice a squared b and ab squared are 2 different animals. They're not the same. So we have a squared b, 2 terms. We're going to add their coefficients. We have a positive 4 and a negative 3. That's a positive 1. Again, if you want to write the 1, be my guest. There's nothing wrong with writing that 1. It's not necessary. If you want to write it, write it. Our next label is ab squared. Notice there are 2 terms. We have a negative 7 and a positive 3, which gives us a negative 4ab squared. We look, and we haven't used up all the terms. We still have this negative a squared. No, just bring it right down. And there's the answer that Kathleen gave us. That is how she got it. Any questions on this? So I said, nice and easy. Nice and easy. Okay, let's extend just a little bit. Let's suppose we have this. the quantity 3x minus 4y plus the quantity 7x plus 3y.
Plus
7x plus 3y. Okay, Leah, what'd you get for this one? Nothing. Help. What do we get for an answer for this? Yes.
10x minus y.
10x minus y. Very good. How did you do it? What did you have to do first?
Same thing before, just on this parenthesis.
Well, so what do you have to do?
Put 3x, add 3x.
No, so you had to do something before you could do that.
Well, we'll take it first.
Right. First step would be remove those parentheses. Remove them. Well, what's understood to be in front of this parenthesis? What do you see there? Positive? What? No. What's in front of this parenthesis? 1. So we're going to multiply everything in that parenthesis by 1. And when you multiply something by 1, what effect does it have? Stays the same. So when we multiply this by 1, we get the same thing without the parenthesis. Likewise here, we're going to multiply this by positive 1. If I do, again, I get the same thing without the parenthesis. Remember, by multiplying something by positive 1 doesn't change anything. Stays the same. So there we have removed parentheses. Now we're back in the ballgame. We know how to handle this. We're going to combine like terms. Those terms that have the same label, we can add. We have an x. We have 7 plus 3 is 10. We have an x. We have a negative 4 and a positive 3 is a negative 1y or negative y, and there is the answer. Okay? Let's try another one. A little variation. Not much, just a little. Let's suppose we have quantity 5a minus 2c minus the quantity 3a minus 7c. Okay, Janet, what'd you get for an answer?
2a minus 9c.
2a minus 9c. How many agree with her? You don't have a friend in class, Jan. Help. 2a minus 5c. 2a minus 5c. 2a plus 5c. Okay. Well, one of those answers has to be right. Let's find out which one. We're going to clear parentheses. Remember, Jan, that's our first step. Get rid of the parentheses. What's in front of this parenthesis is a positive 1. And from the preceding problem, we said we can multiply anything by 1 and it has no effect. It doesn't change anything. So if I multiply this by 1, all that does is get rid of the parentheses. Now I look at the second parenthesis. What am I going to have to multiply everything in there by, Jan? Negative 1. And when you multiply a parenthesis or anything by negative 1, what effect does it have? Rhea, you recall that from your previous algebra courses? It changes all the signs. All the signs. So if I multiply through by negative 1, I get negative 3a and a positive 7c. Okay, Jan? We on the same wavelength now? Good. We're now going to go through and combine those terms that have the same label. We're going to add. We have a positive 5 and a negative 3 a's. That gives us a positive 2a. Our c's, we have a negative 2 and a positive 7. That's a positive 5c. And there it is. Nice, simple. Try one more of these easy ones before we move on to something a little bit more difficult. Make sure you have this. Quantity, 2x squared minus 7x minus 4. And the quantity. Minus quantity, 3x squared minus 2 plus 5x. End of quantity. Minus 4 minus 7x minus 4x squared. End of quantity. How's it, Tim?
What's the second term?
Oh, second term?
Yeah,
In
2x.
the second parenthesis, you have 3x squared minus 2 plus 5x. Minus another parenthesis. 4 minus 7x minus 4x squared. Tim, if you want to move up closer, be my guest, you know.
There's both two minus signs right now.
Yeah. Okay, Michael, get an answer.
3x squared. So I made a mistake. I have to write that over. Plus 5x minus 6.
I didn't get that. Close. Kathleen?
3x squared minus 5x minus 6.
Right, it's minus 5x plus 6. Let's see how we get the right answer. Our first job is to get rid of all these parentheses. Well, the first parentheses, there's a 1 in front of it, so no big deal. We just drop it. Now, in front of this parenthesis is a negative 1. That means we're going to multiply everything in there by negative 1. We know that means change every single sign in that parenthesis. We get negative 3x squared, positive 2, negative 5x. Likewise, in front of this last parenthesis is also a negative 1. That means we're going to change the sign of every single term in that parenthesis. We get negative 4 plus 7x plus 4x squared. And there all the parentheses are removed. Now it's a nice simple procedure, just combining like terms. Getting those terms that have the same label, adding their coefficients. Our first label is x squared, 3 terms. We add your coefficients. We have a positive 2 and a positive 4 is a positive 6. It gives you a positive 6. And then we have a negative 3 added on to a positive 6 gives us a positive 3. And what are we talking about? We're talking about x squares. Now our x's. There are 3 terms that contain x. Now, you have to develop some mathematical insights, intuitiveness. You should be looking for certain things. If you look at this problem, you're going to combine the x's. What do you see there? What do you see that's going to make life a little easier? Yes?
Minus 7x.
Yeah, automatically. They go on. You don't have to worry about those. That's a negative 7, a positive 7. That's always 0. So all you're left with is a negative 5x. Lastly, the numbers. You have a negative 4 and a positive 2. That's a negative 2. A negative 2 and a negative 4 is a negative 6. And there is our final answer. Okay? Nice and neat. Let's see if we can make it just a little bit rougher. Just a little bit. Here we go. Let's suppose I have 3m minus 4h minus curly Q 2h minus m minus bracket 3h minus m minus h in the parenthesis and the bracket and the curly Q. We have 3m minus 4h minus, we have a curly Q. Then inside we have 2h minus m minus bracket. We have a 3h minus parenthesis m minus h. End of parenthesis, end of bracket, end of curly Q. Now you see these all represent parentheses. All these symbols represent parentheses. So what we have parentheses inside of parentheses inside of parentheses. Now our job is to get rid of all of them and then combine like terms. Question is, how do we attack such a problem? What do we have to do? Right, inside out. Attack the innermost parenthesis one step at a time until they're all gone. Okay? See if you can find the right answer for this one.